Okay, we're going to start section 9.2 now. So it's some more characteristics of quadratic functions. This whole chapter is about quadratic functions. So let's get started. Okay. Again, I would recommend getting out your book because see, these things are coming straight out of your book. So if you could follow along, you could see it a little bit better than just looking it up at it on this video screen. Okay, what we're going to do today is we're going to talk about what the meaning of zeros of a function and x-intercepts of a graph. Here's the bottom line. Zeros of a function and x-intercepts of a graph are the exact same thing. That's what zeros of a function are x-intercepts of the graph. X-intercepts of the graph are zeros of the function. So what this thing is saying right here is it says find the zeros of each quadratic function from its graph. Check your answer. So the first graph they give us is y equals x squared minus x minus 2. Now we didn't really have to know that because they showed us this graph. This is the graph of that function. Okay, you didn't even have to know it's that function as long as you know that's the graph. And it says what are the zeros of that function? Okay, what are the zeros? The zeros are the same thing as x-intercepts. So guess what? You look and say, where does this graph intersect the x-axis? Look at 2 and at -1. To me, it's pretty clear, 2 and -1. So those are going to be the two x-intercepts of the graph are also going to be the zeros of the function. So the zeros of that function are 2 and -1. It's that easy. Now, what happens if the vertex of the parabola is on the x-axis, then there's only going to be one zero of the function. And that's in this kind of case. Look, it's -2x squared plus 4x minus 2. The graph of that guy looks like this, right? What are the zeros of that function? Well, they're wherever the graph crosses the x-axis. It only crosses the x-axis at one point right there, and that's the point +1. So 1 is going to be the zero of the function. And then, believe it or not, take a look at this. It's possible for a parabola to open either above the x-axis, opening up, or even if it was below the x-axis, opening down, where it does not cross the x-axis. If it does not cross the x-axis, then there are no zeros. There are functions that don't have zeros. So, don't have x-intercepts. There's graphs that don't have x-intercepts. That would mean there are no zeros of that function. At least in the real numbers, there's not zeros, which is what we know about right now. Okay. So anyways, that's the idea. X-intercepts and zeros, they're the same thing. Okay, so look at this question. Find the zeros of each quadratic function from its graph, okay? So this should be pretty easy. Look, this guy, first of all, look, it doesn't even cross the x-axis anywhere. So the answer to that is there are no zeros to that function. Okay, how about this guy? Well, look, it touches the x-axis just at this one spot at x equals 3. So the zero of that function is going to just be 3. It's that easy. Okay. Now, this is like a summary thing of, let's just go over it. This is in your book. So if you look, I'm not sure what page it's on, but you could find it. It's right in that section there. Okay, here's the deal. A function, a quadratic function is going to have either 1 zero, 2 zeros, or no zeros, just like on that last one we looked. If it doesn't cross the x-axis, it has no zeros. If it does have zeros, it'll either have one of them or 2 of them. It's not going to have more than that. It's not going to have 3 zeros or 4 zeros. It's either going to have 1 or 2. How do you know? Well, okay. If it touches the x-axis, if the vertex is on the x-axis, that's going to mean there's going to be 1 zero of the function, and it's always going to be the x-coordinate of the vertex, right? In this case, the vertex is 3 0, so it's 3 is going to be the thing. So the function has 1 0, use the x-coordinate of the vertex to find the axis of symmetry. Oh yeah, they're wanting to mention the axis of symmetry. The axis of symmetry is a line, this green line right here, that if you were to fold this parabola on top across that green line, say this was on a piece of paper, and you were to fold this piece of paper on that green line, this branch would fold right on top of this branch. That's called symmetry, right? That's why that green line is called the axis of symmetry. The axis of symmetry is always the vertical line that passes through the vertex, right? So vertical lines all have equations x equals a number. So this vertical line is x equals 3. The axis of symmetry is x equals 3. If they touches the vertex, if the vertex touches the axis of symmetry, the axis of symmetry is always going to be x equals x coordinate of the vertex. Now, what happens if it touches at two different spots like this, right? The vertex is not on the x-axis, but the parabola does cross the x-axis. How do you find the axis of symmetry? Well, the axis of symmetry is right smack in the middle of the two zeros of the function, right? It's right smack in the middle. So how do you find a number right smack in the middle of two other numbers? It's called the average. Add them up, divide by 2. So here's how you would figure out the axis of symmetry, which is also the x-coordinate of the vertex, for this problem right here. Okay, let's see where they cross. It crosses at 0 and at, let's see, what is that? 0 and 1, 2, 3, 4, -4. 0 and -4, right? So here's how you would find the axis of symmetry. You would say 0 plus -4 divided by 2. Add them up, divide by 2, and it's going to be x equals that. So that's going to be x equals 0 plus -4 is -4 over 2 is -2. X equals -2 is my axis of symmetry. It's also the x coordinate of my vertex. That means my vertex is going to be -2 something. Okay, in this case, it's -2, 1, 2, 3, 4, -4, -2, -4. Okay, but that's how you find the axis of symmetry given the two zeros. Take their average, add them up, divide by 2. Okay. So, find the axis of symmetry of each parabola. So, this guy right here, the axis of symmetry, since it touches the x-axis, the vertex touches the x-axis, it's just going to be x equals 2. X equals x coordinate of the vertex. There you go. What is the axis of symmetry of this guy going to be? Well, notice the two zeros are 1 and 5. Can you see that? 1 and 5. So I'm going to take the average of 1 and 5. How do you do that? Add them up, divide by 2. It's just going to be 1 plus 5 divided by 2. That's going to be x, right? That's going to be 6 over 2 is 3. X equals 3 would be the axis of symmetry of this parabola right there, okay? Okay, this guy right here, notice it touches the x-axis at 1, 2, 3, -3. So the axis of symmetry there is x equals -3. And then finally, let's figure this last one here. Okay, the zeros are, let's see what they are. Okay, 1, 2, 3, 4. This is 4, and that's -2. So they're 4 and -2. So you add them up and divide by 2. X is 4 plus -2 is 2. Divided by 2 is 1. So you get x equals 1 is going to be the axis of symmetry of that parabola. All right. Now, that was the first thing we're doing today. The second thing we're doing is this. Find the vertex and the axis of symmetry of this parabola. Now, we were just doing that given the graph, and we were finding the zeros from the graph, and then taking the average of those two zeros to get the x-coordinate of the vertex or the axis of symmetry. I'm going to show you a different way to do it. So if you've got an equation in this form, y equals ax squared plus bx plus c, like this one is, here is what you want to do. You want to, first of all, I'm going to show you a magic formula right now. This is very important right here. I want you to absorb this and understand what this is saying, okay? This is, look, for a parabola having this equation, just the general parabola equation, the x-coordinate of the vertex, which is also the axis of symmetry, is x equals negative b over 2a, right? Negative b over 2a. So you just have to use that formula. That gives you the x-coordinate of the vertex. Now you might say, well, wait a minute. It wants us to find the whole vertex, which includes the y-coordinate. This thing only gives me the x-coordinate, and that is correct. It does only give you the x-coordinate. But guess what? The formula itself is a built-in equation for the y-coordinate. These are all going to be numbers, right? So if you know what x is, you plug it in, you'll be able to crank out y and calculate y using the actual equation of the parabola. So I'll show you how we do that now. So I'll go back. I just wanted you to realize that. This is very important. You need to understand that the x-coordinate of the vertex of a parabola is negative b over 2a. Memorize that. Okay, so let's go back. Okay, there's my first equation that I was going to figure out. What is the vertex of this guy? Well, I'm going to use the magic formula, x equals negative b over 2a. So here's my deal, right? I'm going to say x is negative b over 2a. Now, what is a, what is b, what is c? A is what's in front of the squared term, which is 1. B is what's in front of the single x term, which in this case is negative 6. C is the constant, 5. Notice, when you're finding the x-coordinate of the vertex, c doesn't really matter. When you're finding y, c will make a difference. But when you're finding the x-coordinate of the vertex, use negative b over 2a. C is irrelevant at this point. Okay, so here we go. It's going to be negative b. Negative b. Well, wait a minute. What is negative, or the opposite? Let's say the opposite of b. The opposite of b over 2a. What's the opposite of negative 6? It's going to be 6, right? Over 2a. 2 times 1. Just put a 1 in for that. That's going to be 6 over 2, which is 3. The x-coordinate of the vertex is 3. That means the vertex is going to be 3 something. It also means the axis of symmetry would be x equals 3. Axis is going to be x equals 3 also. Okay. What is the y-coordinate of the vertex? Well, that's where I was telling you. We have a built-in formula right here. Look, this is our built-in formula. Y equals x squared, so I'm going to go 3 squared minus 6 times 3 plus 5. Notice, I'm putting 3 in for x right here. And notice, this is all numbers, so it should simplify. Y equals 9 minus 18 plus 5. That's negative 9 plus 5 is negative 4. So my y-coordinate of my vertex is negative 4. So my vertex is 3, negative 4. And the axis of symmetry is x equals 3. That's the two things they asked. Okay, I'm going to do a couple more just like this. Same exact question, pretty much, just a different equation. So, okay. So it's going to be y equals 5x squared minus 10x plus 3. Okay. We want to find the vertex and the axis of symmetry. So, to find the x-coordinate and the x-coordinate of the vertex and the axis of symmetry, I use x equals negative b over 2a. So let's figure out what a, b, and c is. In this case, a is 5, b is negative 10, is negative 10, c is regular 3. So, x equals negative b over 2a. It's going to be, what is the opposite of b? The opposite of negative 10 is regular 10. Okay? over 2a. 2 times 5, a is 5. So I get 10 over 10 is 1. So x equals 1 is the x coordinate of the vertex. That means the vertex is 1 something. It's also the axis of symmetry. Axis is x equals 1. It's always x equals x coordinate of the vertex. What is the y coordinate of the vertex? Well, we're going to go y equals 5 times 1 squared minus 10 times 1 plus 3. I'm putting 1 in for x. Y equals 1 squared is 1 times 5 is 5 minus 10 plus 3. That's going to be negative 5 plus 3 is negative 2. So the vertex is going to be 1, negative 2. And the axis of symmetry we already knew was x equals 1. Okay? We'll do one more. Let's go to this one. Okay. So, okay, y equals negative 3x squared plus 12x minus 6. Okay, so we're going to use our little magic formula. X equals negative b over 2a. So it's going to be, notice a is negative 3, c is regular 12. I'm sorry, b is regular 12, c is negative 6. You keep the signs. Look, c is not 6, it's negative 6 because there's a minus in front of it. Okay, so x equals negative b over 2a. The opposite of 12 is going to be negative 12 over 2 times negative a. 2 times negative 3. So that's going to be negative 12 over negative 6, which is regular 2. So the x coordinate of the vertex is 2. The vertex is 2 something. Okay, so and that makes the axis of symmetry also x equals 2. And let's figure out the y coordinate. Y equals negative 3 times 2 squared plus 12 times 2 minus 6. Now remember, we talked about this already. You go negative 2 squared first. You don't multiply these guys, you raise to the exponent. 2 squared is 4 times negative 3 is negative 12 plus 24 minus 6. That's regular 12 minus 6 is 6. So 2, 6 is going to be the vertex. There's the vertex. There is the axis of symmetry. It's just pretty straight up like that. So, hopefully you guys got a good grasp of that. If you still need to see it, you can rewatch the video. But here's the homework. Homework number 47, page 557, 3 through 24 all, except 18.